of Philosophy or History of Science and Philosophy at the University of Vasile Goldis of Western Arad in Romania. And she also is a researcher that collaborates since a long time ago with the University of Bucharest. And in fact, I met her some 5 years ago when we were working for the special issue on gardens as laboratories, edited by Oana and Fabrizio Baldassari. And then just after that, so just after that special issue, we met in Padua. Wasn't it like this? Yes. And then she invited me to Romania. And so all the group, me, Fabrizio, Alex, now we stay in touch and we are always collaborating whenever it is possible. So you are most welcome. We are delighted that you have accepted this invitation for these seminars. And so now we are willing to hear from you. So the floor is yours. I don't know if the expression is still useful in this context, but well, thank you so much, Oana. Welcome.
Thank you very much, Anna, for this wonderful presentation and for reminding me how wonderful was life before this pandemic. How wonderful it was to travel all around Europe, at least, if not all around the world. And yes, let's hope that it will pass soon, in a way or another. And thank you very much for this invitation. I'm very excited to present my work to you guys, because actually I'm at that point in my career development where I would like to put together a book proposal. And the book proposal will be more or less on what you will hear today from me. So actually, in just a sentence, I'm trying to construct an argument that will claim that in the 17th century, in the mid-17th century England, a new science of vegetation emerged. And that science, I will call vegetable philosophy. It's not my trademark. Actually, it's term used by a guy that I will speak today. I will introduce perhaps this character to you. His name is Ralph Austin. And I will say that this vegetable philosophy is a new discipline, or was, I'm sorry, a new discipline in the 17th century, a discipline concerned with investigating the fundamental processes of nature, such as vegetation. And what is particular for this discipline is the fact that it used plants as instruments to inquire into these natural processes. Okay, so let's start then. I will share my screen now with you. Just let me know if you see my presentation.
Not yet.
Not yet. I wonder why. Now? Yes.
Yes.
Okay. So, plants as instruments of knowledge in early modern natural philosophy. The study of plants and vegetal bodies has always played an essential role in the knowledge of nature for both theoretical and practical purposes. Since the Middle Ages, the practical perspective had prevailed, as the study of vegetation lacked disciplinary autonomy and was primarily an aspect of medical training. Plants were mainly subject to medicinal or pharmacological uses, although a great variety of topics reflected a more comprehensive attention to the vegetal world. Scholars interested in plants generally worked with Dioscorides' Materia Medica, Galen's De Simplicius Medicamentorum, and Pliny's Naturalis Historia, and they learned the uses and properties of medicinal herbs. When Theophrastus de Causis Plantarum translated by Theodor Gaza in 1483, which contained a more theoretical interpretation of plants, was rediscovered and brought back to Europe from Constantinople. This work attracted less attention than Materia Medica, which testified to the medical predilection in the study of plants. Yet a few signs of disciplinary transformations were surfacing in the late 15th and early 16th centuries as a theoretical perspective gained momentum. During the Renaissance, these transformations involved a variety of approaches to the vegetal world, which manifested itself in a slow transition to a botanical discipline, which was more concerned with observations and the description of the entire structure and nature of plants, plant recollecting, res herbaria, catalogs unfolded the knowledge of this period as directed at specimens and aimed at defining a way to classify plants. Parallel to this endeavor, another direction of scholarly inquiry into flora aimed to distinguish the innate principles of herbs and thereby to reveal the sympathetic links uniting the vegetal world with minerals, stars, and parts of the human body. At that time, chemical investigations into the inner properties of plants were gaining in proeminence. Alchemical physicians and scholars such as Paracelsus, Giambattista della Porta, Joseph Duchesne, Oswald Kroll, and Daniel Senner used plants in their experiments as a means to investigate the hidden qualities of nature and the relations between bodies. For them, experimentation with plants was a common way to deal with nature as they searched for the latent processes of life. In the 17th century, plants formed a category of investigation that played not only an epistemic role, providing knowledge about the internal organization, structure, and functioning of plants, it also served instrumental purposes, illustrating fundamental processes of nature, such as vegetation, fermentation, growth, maturation, and putrefaction. And I will clarify this diversity in terminology a bit later. From these various trends, a science of plants emerged incrementally. Investigations of the inner systems of vegetal body, moving from the pharmacological perspective to something that ultimately concerned the very nature of plants. I propose to investigate a 17th century discipline called in Hector's categories vegetal philosophy, chemical history of vegetable bodies, as Bacon calls it, or science of vegetation in the words of Kenneth Digby. This discipline, at the first glance, seems to be concerned with the study of plants, but its final aim is to discover the transformations taking place in natural bodies endowed with sensitive life. This novel discipline attracted practitioners of alchemy, natural magic, natural historians, and other experimenters bound together not by a common theoretical background, but rather by a shared methodology based on an instrumental approach, bottom-up oriented. A chemical history of vegetable bodies does not restrain itself at collecting information about vegetables, but it is ultimately a science of life generation, and investigating life forms. From this perspective, a chemical science of vegetable bodies is a lost science of life characterized by two main features. It opposed medieval and humanistic scholasticism by trying to identify alternative keys of interpreting nature, and it was focused on a process of empirical investigation of nature using new kind of methods, such as experiments, observation, measurements. So my hypothesis is that chemical history of vegetable bodies involves the belief in the possibility of manipulating, through experimentation, hidden entities of matter, whether called spirits, particles, atoms, corpuscles, thus producing two effects: the amelioration of nature or the improvement of the condition of plants, such as, I don't know, growing sweeter fruits or more colorful flowers, and the transmutation of natural kinds from one to another. I am looking at published and unpublished material containing observation, experiments, but also explanations and theoretical considerations dealing with the transformation taking place in vegetable bodies. Key figures are, and I have a list here on my PowerPoint, a list of authors that I looked into. Key figures are 17th and 18th naturalists, such as Robert Sherrock, Ralph Austin, Nathaniel Highmore, Nehemiah Grew, John Woodward, John Ray. Natural philosophers, such as Thomas Brown, Kenneth Digby, Robert Boyle, Robert Hooke. Projectors and developers, such as John Beale, for instance, and other figures difficult to classify, such as John Evelyn or Peter Shaw. They are rarely treated together, and most of the time with theoretical questions in mind. Quite often, their unit of classification was belonging to a particular matter theory or to a particular tradition, such as Aristotelian versus Paracelsian. When scholars looked into the methodological aspects, they classified them as Baconian in the Kuhnian sense, namely qualitative, non-paradigmatic, fact-gathering. I will look at their texts as recordings of inquiries based on a remarkable amount of shared knowledge. Only that this epistemic knowledge has more to do with practices than the epistemology of experimentation, with practices and the epistemology of experimentation than matter theories or the formulation of causal mechanisms and causal explanation. Therefore, I'm investigating a corpus of texts studied by the history of philosophy in a different key, offered by recent developments in history of science regarding practices and the use of experiment. I just want to mention something briefly here, that you know, the classifications that I made in this in my slide here, they are not, the limits are not clear cut at all. So someone that is listed by me in the category of naturalists can be very well listed also in the category of natural philosophers and so on and so forth. Okay. So, a new scientia. This shared discipline is based on the following 3 points, I claim. An instrumental role attributed to plants, regarded as alchemical laboratories, and experiments with plants were used to investigate the chemical processes taking place in these laboratories. Also, a small mention here. According to Bill Newman and Lawrence Principe, up to the end of the 17th century, the two concepts, the two words, alchemy and chemistry, were used synonymously. So there was no difference between what alchemy meant and what chemistry meant. Also, I should mention that most texts in English spell chemistry with Y, C-Y, and you know, it's not I, it's Y, double Ys. So the role of this experiment, so again, when I say alchemy and when I say chemistry is the same thing. The role of these experiments is to investigate plants, not as specimens with different external and internal features for taxonomic purposes based on these features, but rather to treat them as instruments able to perform chemical transformations of matter and to illustrate processes of nature. Often, their starting point was an experiment, an investigation or suggestion recorded by Francis Bacon in his Silva Silvarum, a book which contained 1,000 experiments, a significant part of them being experiments involving plants. Let's call them plants and vegetables. Such was the case of Bacon's hydroponic experiments, which became, in the 6050s and 6060s, a preferred subject for naturalists and natural philosophers, such as Thomas Brown. And I will clarify what I understand by hydroponic experiments in the 17th century. Robert Sherrock, Ralph Austin, Boyle, Beale, Evelyn, all of them were interested in doing experiments with plants set in water. alone, setting water alone, no earth involved. Recurrent quantitative. So the first feature is they use plants as alchemical laboratories to investigate the fundamental processes of nature. So the second feature, recurrent quantitative elements. Do you remember I mentioned that in the Kuhnian sense, these sort of experiments were treated as rather qualitative fact gathering than quantitative. And I'm claiming that we can spot interesting quantitative elements in these experimental investigations. In the 60s, hydroponic experiment acquired new quantitative dimensions, which in turn, allowed the formulation of new research questions and the development of a more sophisticated experimental procedure. And the third element, the use of an operational vocabulary. Naturalists had different theoretical explanations for the continuous and irreversible process of vegetation, and they invoked several mechanisms to make sense of what is actually happening in plants in various stages of this long process. But they tended to treat their explanations as provisional, as we shall see in what follows. In fact, the chemical operational vocabulary used to explain generation, growth, maturation, putrefaction was rather fluid until well into the 18th century, and it was meant to provide a knowledge able to outline the explanatory level. What changed much less was the experimental methodology. And this I will try to reconstruct by having a fresh look at some of the 17th century experiments. We will see how 17th century naturalists used variation, extensions, quantitative estimations, hypotheses or tentative explanations, and various procedures of exclusion to decide between competing provisional explanations in a particular experimental scenario. So the plan of my talk. I will first introduce what I understand by Bacon's hydroponic experiments with plants set in water, and I will look into this experiment because they reflect best the fundamental process of vegetation. It was very interesting because when you set a plant in water, and that plant, whether it starts from a cutting or a seed, that plant develops, actually, the idea is that you can visualize, you can see the process in front of your eyes. So what is hidden in the earth, for instance, becomes visible if you put a seed or a cutting in a vial of water. Then I will introduce all the figures that I've mentioned before, mid-17th century experimenters, natural philosophers, naturalists. And then I will make a difference between what I understand by operational vocabulary and explanatory vocabulary, and I will try to show how this operational vocabulary contributes to the construction of a new discipline. So, Francis Bacon was an English philosopher, but also Lord Chancellor of England that wanted to reform philosophy. Therefore, he proposed an entire plan called the Great Instauration. His plan, outlined in his work, The Advancement of Learning, starts with the classification of knowledge into three main categories: history, poesy, and philosophy. In his plan, natural history is a prerequisite for natural philosophy, and based on experimentation, has to provide the general laws and axioms of nature that will constitute the material for the construction of natural philosophy. So the idea is very simple. Actually, you use natural history, which is fact gathering and collects information about nature. And based on that collection of information, you extract general laws and axioms of nature. And using general laws and axioms of nature provided by natural history, you construct natural philosophy. That's why natural history is prerequisite for natural philosophy in Bacon's understanding. Bacon is very well known for providing a method for the investigation of nature. In his Novum Organum, he proposed two ways of inquiring: interpretatio naturae, a new logic of research based on the collection of natural facts and their inductive investigation, and experientia literata, which proposed way of extending experimental techniques. So we have the interpretatio naturae, or new logic of research based on collecting information about nature, and experientia literata, which allows you to extend procedures from one experiment to another. Bacon wrote natural histories, some more theoretical, such as his Latin natural history, Historia Vitae Mortis, for instance, being one that is interesting for the topic that I'm presenting to you today, and some more practical, such as Silva Silvarum. Published posthumously, Silva Silvarum contains a significant number of observations and experiments concerning plants. A significant number of these experiments may be classified as hydroponics. They treat a number of topics, such as plants growing in water and with water only. Among the plants subject to registered trials are pennyroyal, damask rose, watercress, tulip, and mint. Mint was a very interesting category because of the smell, and because they consider that the most odorous a plant is, the better the illustration of transforming water into something different is evident. Seed nourished with watery nutriments or sprouting in humid environments, onions and other bulbous plants sprouting spontaneously, hanging in the air in a humid environment, they just grow. They sprout spontaneously. Plants feeding on water at a distance, plants growing on other plants from the sap of their hosts, either by spontaneous generation or by techniques such as inoculation, grafting, or grafting in the root. Don't ask me many technical questions about this, because I'm not an expert. I'm just reconstructing the philosophical part of this.
Eu vou aí amanhã, teoricamente. Portanto.
Sorry, just one moment. Everybody has to turn off sound. We are listening to a mobile phone.
Mas, Ana, eu acho que podes desligar os microfones como organizadora.
É a Patrícia. Não sou eu.
I'm going to do it now.
Okay. Sorry, Oana, you can continue.
No worries.
Sorry, just a second. I think I made something. Oana, you can activate your sound. Yes, thank you.
I did that.
Thank you.
Okay, so this collection of experiments with plants set into water is illustrative for a certain conception of chemistry. Central to this conception is a universal process of, I'm sorry, I shouldn't have done that. Okay. Of transformation, which takes place, in Bacon's opinion, everywhere in the sublunary world, in the region between the tract of the air and the subterraneous, called inner parts of the earth. Bacon uses for this process a very generic name, borrowed from the Aristotelian or perhaps the medical tradition. He calls it concoction. In Bacon's terms, concoction is a gradual, irreversible transformation which takes place everywhere, and it leads to the transformation of metals and minerals from mercurial to sulfurous under the influence of heat and celestial radiation. On the surface of the crust, it makes the soil fertile to the production of saltpeter. It also transforms water, which under the influence of the heat of the sun becomes nitrous or sulfurous. So to simplify things, in Bacon's opinion, there are different quaternions of matter. This is how he calls them. So groups of matter, huge categories of matter. And one is watery or mercurial, and the other one is oily or sulfurous. the transformation from watery to oily actually is what happens, the transformation of watery into oily, I'm sorry, is actually what happens in this process of concoction, which takes place all over the place in the sublunary world. It produces spontaneous generation of plants and animals and even transmutation of species. In the Silva silvarum, concoction is a widespread fundamental term. It is used as a substitute for digestion in plants and other tangible matter which does not have organs of digestion. It is such as minerals. It is used to classify plants, fruits, odors, tastes into better concocted, more oily, cruder, watery. Metals are also said to be better concocted than other metals. Some metals are better concocted than other metals. And the fertility of water or the soil is also a result of the measure of its concoction. The more concocted the soil is, the better plants will grow out of it. So we have here an attempt to formulate a definition by Bacon of concoction in Silva silvarum. So the passage is rather long, and I will ask you to, I'm sorry, what do I do here? Okay, I'm good. I will ask you to take a look only of those phrases that I have underlined. The word concoction or digestion is chiefly taken into use from living creatures and their organs. Therefore, they speak of meat concocted, urine, excrements concocted. It signifies the degrees of this concoction should signify the degrees of alteration of one body into another, from crudity to perfect concoction. It is true that concoction is in great part the work of the heat, but not the work of heat alone. For all things that further the conversion or alteration, as mixture of a body already concocted, are also means to concoction. And there are of concoction two periods, the one assimilation or absolute conversion and subaction, the other maturation, whereof the former is more conspicuous in the bodies of living creatures, in which there is an absolute conversion and assimilation of the nourishment into the body. And likewise in the bodies of plants, and again in metals, where there is a full transmutation. The other, which is maturation, is seen in liquors and fruits, right? I mean, in cider, for instance, which is a fermented drink. A living body, by concoction, grows, develops itself, such as a plant or an animal, or even the human body. Right, so we assimilate the food that we ingest, and we concoct it in our stomach, and therefore we grow mature. And the other process, fermentation, is visible in the case of fermented drinks. But note that there be two kinds of absolute conversion. The one is, I think I misplaced them. When we assimilate food is conversion, I'm sorry, and maturation is in the case of fermentation. The one is when a body is converted into another body, which was before, as when nourishment is turned into flesh, that is which we call assimilation. The other is when the conversion is into a body merely new, and that which was not before, as if silver should be turned to gold or iron to copper. And this conversion is better called, for distinction's sake, transmutation. So what happens to an apple that ends up cider is transmutation, according to Bacon, right? Is as if you turn silver and transmute it into gold. So what's clear from this definition is that Bacon uses concoction as an umbrella term to designate a wide range of continuous and irreversible transformations. So you cannot transform a fully grown plant into a seed, as you also cannot transform cider into apples, right? But in the same manner, you should not be able to transform artificial gold into silver again. Unlike rarefaction and condensation, another universal process in Bacon's universe, concoction is unidirectional. Again, you cannot reverse it, right? There is no converse process which can turn concocted meat into crude, ripened fruits into raw, concocted water into pure water. Like rarefaction, concoction, do you remember the image that I have here? We have two important processes for bacon. One is pneumatization, rarefaction, which takes bodies from dense to rare, and the other one is concoction, which takes bodies from watery to oily or from mercurial to sulfurous. The difference is that rarefaction is reversible, while concoction is not reversible. Okay, so like rarefaction, concoction is a process triggered by heat and celestial radiations. It is a process of pneumatization in which tangible matter acquires more spirit, and spirits themselves get better organized. This is the Baconian language. Being more organized means that they can be evenly distributed or better organized in terms of branching. However, for instance, I will come again to the example with cider. What happens in terms of theoretical explanations is that spirits that are present in apples are better organized in the case of a fermented drink such as cider, right? So the transformation of apples to cider is a process in which the spirits present in apples gets better organized and they become more finer, as Bacon says. However, in many respects, concoction is more general and more fundamental than rarefaction and condensation because it affects what Bacon calls the deepest, most fundamental schematisms of matter, the truly primordial categories of nature. This is why concoction can take place everywhere inside the earth, in metals and minerals, in water, in the crust, in plants and animals, inside the human body, in the region of the air, in the ethereal regions. But this is also why concoction is, at least in its ultimate complete form, that of transmutation, right, transmuting apples into cider, is magnalia naturae. It amounts to nothing less than a drastic change of the configuration of matter with the result of producing new forms and sometimes new species. Bacon is adamant. Concoction in plants, namely turning water or watery juice into oil or oily juice, is greater in nature than to turn silver and quicksilver into gold. So thus, plants are the best alchemical laboratories. They do naturally and daily what the alchemist is struggling to imitate in his lab. Therefore, the investigation of plants is a proper chemical natural history. Okay, Bacon's hydroponic experiments are not explicitly quantitative. However, quantitative desiderata are clearly formulated in the Silva Silvaro. We can even find suggestions of how to turn experiments into quantitative investigations and how to estimate how much water was turned into something else. We observe it in plants simply because plants are good instruments to display various phases of concoction, and perhaps they are also simple enough to facilitate hands-on experimentation and manipulations. Hydroponic experiments are such experimental investigations in which the experimenter can isolate the various factors leading to chemical transmutations. And they also have the potential to become quantitative, namely to fulfill the Baconian requirement that everything having to do with powers and virtues has to be measured, weighted, and computed. we can see their potential to follow Bacon's precepts of gathering into his natural histories as much exact inquiries as possible, and to compute in each instance, and I'm quoting now from Bacon's Novum Organum, what is lost and given off, what stays behind, what enters, what is dilated, what contracted, what is put together, what separated, what is continued, what cut off, what spurs on, what curves, what dominates, what yields, and much else besides, unquote. So now let's move the discussion to mid-17th century naturalists that followed, that methodologically, followed Bacon. So there were two explanations of what's happening in this process of, let's say, concoction or vegetation. The first one was the Aristotelian explanation, but this is rather seen as an internal growth, the actualization of the form in the seed. So we have the form and the seed, by developing to a mature plant, doesn't do anything else than to actualize the form. And the other one was the Van Helmontian explanation, which took water as the formative principle, the material cause for all sublunary bodies. So there are seeds in water, seeds not as seeds in plants, but seeds as universal seeds, which encapsulated the archeus, which was the efficient cause or the inner principle of transformation. So these were, let's say, the most important two explanations for what's happening into this universal process of concoction vegetation. These were the theoretical explanations. There was also a very famous experiment, perhaps you have already heard of it, the willow tree experiment. What Van Helmont did was to take a cutting of a willow tree and also a pot of earth to dry in the oven the entire earth, the entire quantity of earth that was in that pot. So he tried to dry it as much as possible, to weight it, and then to put the cutting in the weighted pot, in the weighted earth pot. He added water, he claimed, for 5 years. So he added water constantly, and the cutting developed into a nice branch. After 5 years, he took the earth again from the pot, he dried it, and surprisingly, he realized that actually the quantity was more or less the same. I think actually the quantity was a bit less than 5 years ago when he started the experiment. So actually he concluded that the water did the entire work, that earth was just a medium, that earth provided just a medium for the development of the plant. So that was the very famous, in the 17th century, willow tree experiment, which was more or less retested, improved, developed by different experimenters and naturalists. So questions about the material and the efficient role of water for the development of organic life had at least two origins in the mid-17th century. One was the direction set by Jan Baptista van Helmont, investigated the inner formative aspect of the principle of water in the production of every sublunary thing. And the other one was what Charles Webster, an important 20th century historian of science, called the water culture experiment. Attempts at popularizing experiments focused rather on proving the nurturing capacity of water. As I told you, the willow tree experiment was very, very famous in the 17th century. Both directions of investigation, both directions of investigation were based on experiments with plants set into water alone out of their earthly medium, and in the 6040s and 6050s, we can find a wide range of them in the experimental recordings of Thomas Brown, Ralph Austin, Robert Sherrock. Later, they get picked by Robert Boyle, Nathaniel Highmore, Robert Hooke, John Woodward, John Evelyn. Important to note is that although the Helmontian theoretical and experimental frameworks were known by the aforementioned people, their own experimental endeavors were not simply variants of the willow tree experiment. Rather, their efforts could be originated in Bacon's own collection of experiments in Silva Silvarum. Bacon was also aware of the theories of the important theory, at least the important theory. I'm sorry, is this visible for you? My update to Adobe Flash something? No, right? Sorry, because it just popped up from my computer. I'm sorry for that. Bacon was very aware of this other explanation that water is actually the cause of everything. Apart from the direct connection to Bacon, such as in the case of Ralph Austin, who wrote a book called Observations upon Sir Francis Bacon's Experiments in Silva Silvarum, and Robert Sherrock, who wrote another book which is called History of Propagation and Improvement of Vegetables, in which he clearly ascertains the influence of Bacon in his case. So except these two cases, methodological and theoretical elements testify for the Baconian association. Therefore, experimenters did not restrain themselves at retesting the willow tree experiment, but they placed several other plants, cuttings, and seeds into water, and sometimes even tried to compute the results, as Van Helmont did. Some of no, I'm sorry. This is extra to what Van Helmont did, because Van Helmont did not compute the quantity of the plant, the grown plant in the timeline of 5 years. Some of these experimenters got engaged in collaborative enterprises, communicating and exchanging experimental information. So they were sharing experimental techniques, and also results. Also, in other cases, the experimenters recognized the propedeutic role of natural history for the development of natural philosophy. Their reasons for doing these experiments could vary widely. Some, such as Thomas Brown, were mainly interested in discovering fundamental properties, such as the seminal reasons of water. Others were focusing on investigating the stages of what they believed was a universal process of concoction, conversion, or transmutation, including the last stage of its spontaneous generation. Quite interesting, despite the different theoretical reasons, their experiments preserve a certain methodological unity, also with respect to quantitative aspects, and they are almost always introduced as variations and extensions of the same common core of experimental investigations. You remember that I mentioned that I claim that one of the important features of this new science is that it uses a Baconian methodology of experimentation based on what Bacon describes in his Novum Organum as in 2 steps, right? A process in 2 steps, the interpretatio naturae and experientia literata. Bacon's Instauratio Magna, his plan for changing natural philosophy in general, presents the methods to inquire into nature, interpretatio naturae, and experientia literata. The first instructs the investigator on how to observe nature, while the second advises how to move from one experiment to another by variations and extensions. So what if the interpretatio naturae give precise instructions on how to observe nature, experientia literata allows the experimenter to move experimental techniques, for instance, setups, from one experiment to another, from experimenting with the willow tree to experimenting with milk, for instance. Our characters recognize the Baconian source And often they also refer to each other's investigations, building on previous knowledge, practical as well as theoretical. They also share the way to conceptualize plants in terms of chemical instruments. Sometimes we can find this addressed explicitly, as for example, when John Bill compares, and I quote, the motion of sap in vegetables to the descent of liquors in an alembic, unquote. And the tree with an instrument of distillation. And when John Evelyn claims, for instance, that the juice of fruits and vegetables is nothing else than better, and I quote again, concocted water, unquote. One thing our characters do is to extend Bacon's list of plants, which can grow with water and water only. Thomas Brown experiments, and I have here 4 covers of 4 books, all of them published in 1658, so it was something in the air that year. One is Austen's observations upon Sir Francis Bacon's natural Silva Silvarum. The other one is Robert Sherlock, the history of the propagation and improvement of vegetables. The third one is Robert Boyle, the skeptical chemist, a very influential book, not just for the study of plants, but for the study of nature and living bodies. And the last one is Thomas Brown's, Garden of Cyrus, which is a very complex book that can be classified in various ways, such a topic book or a natural history of a garden. So again, it's a very complex book. What is also very important is that all those 4 people were communicating to each other. And they shared letters and experiments, sometimes directly to one another, and other times the correspondence was mediated by other people, one of them being Samuel Hartlib. Samuel Hartlib was a hub of correspondence. I know his circle was pretty much involving all the important figures in the mid-17th century, Central and Western Europe. So you will find people like Descartes there, and I don't know, Boyle, as I mentioned, Dutch philosophers, German natural philosophers. One thing our characters do, again, is to extend Bacon's list of plants. Thomas Brown's experiments and the trials performed by Ralph Austin and Robert Sherlock in Oxford in 1658 do precisely that. In fact, one can see in these experiments an explicit attempt to use hydroponic experiments in order to produce a new system of classification in the vegetable world. One can thus use the capacity of a plant to convert water into nutrients as a basis for classification, first into hydroponic and non-hydroponic plants, and then into species according to how much they can survive in water, whether they can develop roots, sprout buds, and develop leaves and flowers. Thomas Brown was clearly interested in plants that had survived in water for years, while Robert Sherlock develops a full classification in his published History of the Propagation and Improvement of Vegetables. Sherlock establishes 3 categories of plants. Let me move to Sherlock. Okay, yes. So first, there are those which set in water did not grow at all. And he mentions mugwort, rosemary, stock gilliflowers, alaternus, lavender cotton, sage, armerias, chamomile, rosemary, Polinum montanum. Some of them corrupted before developing roots, such as stock gilliflowers, bane, tamfi, groundsel, lavender cotton, sage, majoran, while others, although developing leaves and sometimes even roots, altered and died before attaining maturity. Basil, mint, marshmallows after it had grown, a span, Panax colony, Balsamita minor. The last category, yes, I should have shown on this slide. The last category of cuttings that can develop in water are able to convert water and grow with water only. This category can be further divided according to the particular ways they perform the conversion of water. One further experimental investigation Sherrock embarks on is a turn towards performing quantitative assessments of how much water gets converted into how much oil in the chemical laboratory of a hydroponic plant. And I will quote, I will read this quote, I'm sorry. Plants that increased in weight being planted in the water were these, and the quantities thus much. Sedum multifidum in a month increased in weight, half a scruple. Scordium as much in a fortnight. Dorias, his woundwort grew in 6 weeks, 13 grapes. Bugula in somewhat less time grew 50. Watercress grew 25 in a month. Ranunculus half a scruple in 6 weeks, and periwinkle as much. Prunella, brookline, scordium, and most of the sorts of mint got weight proportionally. Similar quantitative experiments can be found in Thomas Brown's recordings, where he often notes how much water was consumed for a plant to grow a number of inches taller. But Brown also realizes that the conversion of water into the body of the plant is not all that happens in this process of concoction. At least a part of water is not concocted, but gets rarefied and leaves the body of the plant to processes of percolation and filtration, which look deceptively similar with perspiration. He noticed droplets of water that were found on the leaves of the plant, or respiration. By cutting the top of a plant, one can increase its capacity to draw water, which presumably means that at least a part of the sap evaporates in the air. Brown shows that these side processes are important and need further investigation. And here is a passage from his Garden of Cyrus. How much humor is exhausted by a single plant and what perspiration necessary is evidenced in a plant that grows in a glass, wherein a single plant of balm or mint will in a summer exhaust a gallon of water, whereas rue or a woody plant that only lives without shooting root will not make more sensible exhaustion than what is conceived the sun made in a narrow muted glasses. Among other things, Brown's new line of investigation into the respiration and perspiration of plants allowed further refinement of the classification of plants according to their chemical properties, and opens up investigations into the mechanisms and organs through which perspiration and respiration are performed. For example, Brown experimented with the ways in which leaves absorb water and sometimes even convert water into oil, as in the case of dry bay leaves, which can be resurrected when the branch is put into water. Other investigations, such as Beals, who inquired into the respiration of plants by examining the role of air to the development of plants. In an attempt to show that air is as essential for plants as for animals, Beals suggested putting flourishing plants into pneumatic or rarefying engine of Mr. Boyle, the vacuum pump, to see if without air they wither or not. Also in another trial, Beals suggests to put in a vial of water from where the air was pumped out, plants that can grow in water alone and see if they should. Similar investigations were attempted with seeds, pursuing to show that like fully grown plants, they need air, water, and heat to sprout. The hydroponic experiments developed in the 60s in and around the Royal Society of London for the improvement of natural knowledge, which was founded in 6060, and for those who are not familiar with this society, is a learned society whose main aim back in the 17th century was to acquire knowledge about nature by experimental investigation. The society still exists today, and from its very inception, the society published the journal Philosophical Transactions. The journal is still published today. The society is made of fellows elected at the recommendation of an already existing fellow, and famous members are Isaac Newton, J.J. Thomson or Stephen Hawking. So the experiments developed in the 60s around the Royal Society, in and around the Royal Society, was used to further experimentally elaborate some questions regarding quantitative aspects, such as computations involved by this type of experimentation. Apart from inquiring if plants can grow in water alone, it was also interesting to see how much quantity of water is transformed into how much quantity of plant. For example, we can find in Boyle's Skeptical Chemist a trace of such recordings, which are clearly aiming to weigh and measure how much water was converted in the process of growth and maturation of a plant kept in a water vial. What Boyle did was to distill the resulting plant, so he distilled the plant and compute the amount of oil, watery residue, and caput mortuum one gets out of the laboratory. I'm sorry, I have to plug in my computer. Why was important to compute all these substances? Because the point is that actually what happens in the process of vegetation or a concoction is to transform matter from watery into oily. So computing, distilling first the resulting plant and then computing the quantity of oil that you get actually proves for this transformation in nature. And we have the passage from Boyle. And I will read it as quick as possible. And one of these vegetables, cherished only by water, having obtained a complete growth, I did, for trial's sake, cause to be distilled in a small retort and thereby obtained some phlegm, a little empireummatical spirit, this is alcohol, a small quantity of a dust oil, and a caput mortuum, which appearing to be a coal, I concluded it to consist of salt and earth, but the quantity of it was so small, the caput mortuum, that I forbore to consume. Okay, good. So he computed what he got. In the same line of quantitative inquiries in the late 60s, John Beale aimed at showing that the sap of a tree is much heavier than one would imagine, and he refers to the experiment done by Rattray, the learned spot. This is a doctor, his name is Dr. John Rattray. He was also interested in natural natural experiments with nature, I'm sorry. Beale refers to the experiments done by Rattray on tapping the juice of trees and weighing it, and examines how much water is converted into the body of the tree. Beale compares this process with one of the distillation and with the tree with an instrument which is capable of changing or transmuting water. And what I have here is an extract of the Philosophical Transaction, the article where Beale advised to set plants in Mr. Boyle's vacuum pump, right, the pneumatical engine. How much time do I have, Anna? Okay, so and so. So I have to be, okay. Do I still have 5 minutes?
Yeah, sure.
Okay, great. So the last part of my talk, which will be short, the operational vocabulary. I'm claiming that in building this new discipline, this new scientia, natural philosophers and experimenters use different concepts and different terms, different words, but I'm taking this as a sign to try to delineate and to clarify the limits of the new discipline structure. So that's why I'm saying that they used their vocabulary was rather fluid, because it was just a step in building up a new discipline. So this fluidity of terms. So when dealing with all these chemical transformations taking place in plants, our authors use a diversity of terms. They also invoke a large variety of theoretical explanations. This is very important. All those people believe in different theories, but disregarding their different beliefs, different theoretical beliefs, they were able to work and experiment together. So what we are witnessing here is not a case of applied science, but on the contrary, is a bottom-up oriented science. Some, like Brown, believe in the seminal principle incorporated in water. So the water has seminal formative principles, like in the case of Van Helmont. Others explain the conversion in corpuscularian terms as produced by the motion of agitation and separation of particles. And this is the case of John Woodward, for instance. And we will see that I have a quotation from Woodward in which he compares plants with machines. Some appeal to Helmontian principles, that water is, the source for all sublunary things. Others retain the elements of the Aristotelian explanation. Some, like Sherrock, for instance, he black boxed the explanation altogether and used generic terms such as concoction and conversion to refer to general processes of transforming water into oily products, and he tried to remain faithfully Baconian in constructing natural historical accounts instead of theoretical explanation. He argues that clearly in his book. He says that my book is just a natural historical attempt. I'm not doing natural philosophy here. Even in the more theoretically oriented work of Nehemiah Grew, the idea of a phytological history propounded. The preface insists on a solid investigation of nature without taking into consideration any particular matter theory, not even any principles or discourses of Cartesius, Gassendus, other material causes. In his work, Grew uses terms such as fermentation and digestion, but also motion of corpuscles, mixtures, and minima naturalia. In this, he is not alone. The same multitude of terms can be found in Evelyn Heim or Sherrock Bacon himself. So I have a small quotation here from Grew in which he claims that the general cause of growth of a bean or other seed is fermentation. In a similar manner, when talking about the fundamental process of nature that puts particles of matter into motion, Evelyn calls it in the pages of the same manuscript either fermentation or concoction. I'm not going to read these quotations because you see, we have the word fermentation in the first paragraph, and then we have the word concoction in the second paragraph. So again, Evelyn used all these terms in an operational manner. When he moves the discussion in a later work, a philosophical discourse of Earth, because the two quotations were from his Elysium Britannica, an unpublished manuscript that was started in the 60s. So in a later work, philosophical discourse of Earth, published in 1676, he calls the process of transforming something that is watery into something that is oily, something that is less organized in nature into something that is more complex, concoction. So my suggestion is, and I finish in 1 minute. My suggestion is that the way to make sense of this multiplicity of terms is by distinguishing between two types of theoretical vocabularies. I also have here, but if anyone is interested in, we can come back to this table. I tried to identify what terms are used by certain natural philosophers. So we have to distinguish between two types of vocabularies. The first is a phenomenological, operational vocabulary, which describes the hydroponic experiments in terms of the conversion and transformation of water and watery products into oily and oily products. Terms such as concoction and digestion, conversion belong to this vocabulary. And we also have an explanatory vocabulary that will try to provide theoretical explanations. Also, at this level, my characters used a variety of terms because the meta theories that they believe in, again, they came from different directions, such as Bacon, he believed in a matter theory formed of spirits. Others were Cartesians, and they saw the universe as made of particles, as in the case of John Woodward. But what I wanted to point here is that although Woodward regards plants as machines, the transformations that these machine plants do is an irreversible one. And in a Cartesian universe, you know, a mechanical universe is characterized by the fact that all the processes are reversible. So in this case, although the explanation, the theoretical background of Woodward is a corpuscularian one, he agrees that the processes of nature, such as vegetation, concoction, fermentation, are irreversible. Okay, so as conclusion, in the 17th century, hydroponic experiments had a life of their own. They were reproduced and diversified, extended, and transformed into quantitative experimental inquiries. I have shown that these experiments display a curious stability and unity which transcends theoretical and metaphysical differences between authors and allow conversation and communication to develop across groups with different theoretical commitment. I suggest that we can treat the common features behind this curious stability in terms of a disciplinary unity. And I suggest that this disciplinary unity was largely given by the system of practices described in Bacon's projects of natural and experimental history. The chemical, natural, and experimental history is not a theoretical science. In fact, theories count little in this compound. This disciplinary unity is given by common methodology defined through experimentation and a sort of instrumental approach that allowed the naturalists to treat plants as laboratories for the investigation of chemical transformations. Although they largely agreed on the experimental methods as well as the quantitative dimension involved, these naturalists used a provisional, methodological, and sometimes operational vocabulary to describe their investigations, and this serves as the foundation to construct a more sophisticated explanatory language. Thank you. You should turn on your
Thank
mic.
you so much, Oana. It was great.
It was long, at least. It was long.
Yes, it was, but I have several questions. It was really very good. When we are interested in experiments on plants and with water, this is absolutely amazing. It's open for discussion. So if you have any questions, please stand your hand and yeah. Okay, so if not, I'm going to ask you something. Do you find any connection between this and other treatises that deal with plants, such as agronomic and garden treatises?
Other treatises such as?
Agronomic and garden treatises.
Well, yes, actually, I don't know, it's very difficult to classify. I mean, in the 17th century, it's very difficult to classify works belonging to several authors, because, you know, all these disciplines like agronomy or horticulture, they were not defined in the mid-17th century. So I'm on, you know, an uncharted, unmapped territory. But I'm, you know, the paper that I delivered, the talk that I delivered to you today, inquired people that were connected to the Royal Society.
Yes.
And I think we can consider them more or less natural philosophers. Meantime, I discovered a number of other authors that were not connected to directly, at least, to the Royal Society, and they wrote different tracts on, I don't know, for instance, what's his name? He wrote Vinetum Britannicum, and he was the first English author to systematize agriculture and to plead for a systematized sort of, for a systematized system of agriculture in England. Just give me a minute, and I'm gonna come with his name in a second. So yes, if we, let's say, consider two different categories of works, the ones that I presented to you today as being natural histories, natural philosophies, and then if we take other works such as this one, just a second, Vinetum Britannicum. So that's John Whirlidge. I'm going to write his name.
Oh, I know.
Name, okay, I'm going to type his name in.
I know. And also husbandry books or books on husbandry. I think they also have some kind of applied experiments that can be connected with this.
Absolutely, yes. That's my claim, that actually this new discipline was not restrained to people connected to the Royal Society. A number of other writers, let's call them writers, okay, a number of other writers interested in agriculture, beekeeping, cider making, horticulture, gardening, were also part of this enterprise, right? They did not have necessarily philosophical intentions, right? They were not interested in writing a natural philosophy, but they were very much interested in finding, by the use of experiment, that's very important, right? By the use of experiment, they were very, very much interested in finding ways of producing better techniques, better products, right? To to grow, pasturing also, how to grow improved apples or improved all sorts of fruits, right? So how to systematize agriculture, right? Also in tracts of husbandry. So again, this discipline actually is more popular in the 17th century than it looks at the first glance, and it involved many minds and many hands.
And I'm also thinking that it's not only that it would interest a broader audience besides the natural philosophers, but I also think that these other guys, they were doing it sooner. So I would think about the 16th century. And maybe I would say here in the Mediterranean.
I'm sorry, I'm not an expert on what happened on the continent. So I don't have an opinion on that. I only studied English sources.
Okay.
But I think you're right. And this will be something very interesting to me and to my future investigations, for instance, to extend the domain to what happened on the continent, right? Because England was not something different. And I mentioned before Samuel Hartley. Do you remember the name?
Yes, yes.
So he actually he was a refugee of the 30 years old war, a refugee from the continent to London. Well, it's debatable. the city where he came from back then was in Poland and now is in Germany or something like that. So it's difficult to say whether if it was Polish or Prussian, it doesn't matter. However, he was a refugee from the continent to London, and he kept a huge correspondence on different topics, such as, for instance, I don't know, husbandry topics with people spread all over Central and Western Europe. So that's, I don't know, a very good starting point for my research, future research.
And then you also have the botanists like Clusius, Garcia da Horta, and all those that are from the 16th century and were also making experiments or studying plants.
Well, I'm not sure how much into experiments were they. They were for sure into observations. I completely agree with that. They were on studying plants as studying them directly, not using books. And they were very much interested, I think, in taxonomies. While the people that I'm working on were not, you know, again, the difference I think is the perspective. While botanists, as you mentioned, have a sort of up to down perspective. So they have the science. The idea is to improve the science that we already have. What I'm speaking of here is the emergence of a new discipline, which was bottom-up oriented. You know, starting from experiments, we can build a new discipline. And the ground that we are building on is based on the method of experimental methodology. That's what we are working with. Another tool is using plants as instruments to inquire into the universal processes of nature. And the third one is the use of an operational vocabulary in spite of all the theoretical backgrounds. I'm dealing with people that believe in corpuscles, as well as people that believe in spirits active in matter. So although they believe that matter was formed by different entities that worked in different ways, so spirits are active upon matter in a completely different way than corpuscles, which are interacting and collide with each other. So in spite of all the theoretical differences, they found a way to work together, to share experimental techniques and recording results. And that, I claim, is by using the terminology in an operational way. So it doesn't matter what we understand by fermentation, what we understand by concoction. It's not important at this stage in the formation of this discipline. It is important to develop experiments, to extend them, to see what we get, to improve, because the practical part of all their endeavor is, I don't know, major. Perhaps the practical part was the first and the foremost, right? They were willing to, again, to grow. Ralph Austin, for instance, he bought land in Oxford and he grew a number of orchards, and he was able to, that's a funny thing. He was very famous for the cider he made. So Isaac Newton ordered some of his very famous cider because he wanted to taste it. So again, this guy, Ralph Austin, he bought land in Oxford just to go in the field and see by repeated trials how can he improve the cultivation of the land in order to have better fruits, better apples, that can make excellent cider. Also, again, so the practical aspect was vital, of course, there was also an economical aspect which should be not overlooked here. You know, I was mentioning cider many times. Well, think of England in the 17th century. They were dependent on wine imports from Portugal, Italy, Spain, countries that were not best friends, you know, at the time. So the idea to develop a national beverage that can, you know, be produced from the beginning to the end in England was a very important desire that time. So also we have an economic aspect, but all these aspects, I mean, the practical, the economical, they do not affect the disciplinary unity behind all those experimental trials. Should I go to, can somebody help me? Because I was not able to read what's written in the chat. So how about Anna?
We have two questions here for you.
Okay.
The first one is asking if you are familiar with the concept of vitalism.
Yes.
So
Bacon, you know, speaking of his theory of spirits, so he is included in the category of philosophers that you know, believe in vitalism. Again, the boundaries are not clear-cut. It's very difficult to pinpoint to a mid-17th century natural philosopher and say that this guy was Cartesian, this guy was, I don't know, Baconian, because everything was mixed up. Again, it was the example with, for instance, Boyle, right? Robert Boyle, who took the willow tree experiment, and not just the willow trees. He had the Skeptical Chemist, the book that I introduced you in my slides, was a book in which Robert Boyle tried to explain what nature is made of, what kind of natural processes one can encounter in nature, what kind of entities are animating matter, and in what manner. And although Boyle believed that matter is made of particles, so one could say that he's kind of mechanical, philosophical oriented. Actually, what you get from Boyle's natural philosophy is that, yes, matter is made of particles, but some particles are endowed with special powers. So it was very difficult for someone who believed in mechanical philosophy to explain universal processes of nature, such as growth, right, vegetation, only by appealing to mechanical explanations. In the same manner, those who are vitalists, those who believe that matter is animated by, I don't know, special entities, right? They started to believe, I mean, Cartesianism was very popular, but then, and they started to, you know, to mix vitalism with mechanical philosophy, vitalism with chemical interpretations of nature, such as Van Helmont's or Paracelsian interpretation of nature. So everything was very much mixed up in the mid-17th century. And yes, to answer your question, vitalism was a very important theory on the table.
Sorry, can I just ask, can we have authors that were mixing both of them, and alchemy?
Alchemy, of course. Boyle, for instance, the skeptical chemist is the skeptical alchemist, actually. I mentioned Newman and Principes inquiries into the use of alchemy and chemistry in the 17th century. Yes, Van Helmont was an alchemist.
And before?
Before who?
Before them, Boyle and Van Helmont.
Well, Van Helmont is a bit earlier than Boyle. What do you mean? I'm trying to cover the 17th century.
I'm trying 16th century.
I don't know 16th century.
Okay.
It's not my cup of tea, unfortunately, but I can tell you that Bacon, for instance, who, if you want, is late 16th century, early 17th century, he mixed alchemy, vitalis, via alchemy, with not with mechanical philosophy, because it was not necessarily in place back then, but with other explanations, such as the spirits. For Bacon, matter is made of spirits, but the way in which spirits work in nature and the kind of transformation their activity in nature produce is, in the case of concoction, for instance, is a chemical transformation. And if you want, there is a seminal, two seminal papers, because it's a paper in two parts, written by Rees, which is called the Semi-Paracelsian Bacon. It was published. I'm sorry,
can you repeat? Sorry.
I'm gonna
okay,
write. I'm gonna write in chat. Okay.
Thank you.
So you can have the reference
the connection. Yes, thank
you. Okay.
So it was a great session. In fact, 1 hour and a half shows that also the interest that the public show on the topic. So it was a very, very interesting session. Oana, thank you so much. And also thank you for all the participants for attending this session and for participating in the discussion. So I think these sessions that we have started in January 2020, then it was interrupted between March and September because we were all so stressed and finding ways out of the pandemic, how to continue to work in a different way. Well, we have discovered Zoom, so everything now is by Zoom. So in October, we resumed these sessions, and now it's each month one, and I'm so pleased that Oana has been our first foreign speaker. So thank you so much, Oana. Okay.
Thank you very much for having me.
Hi, Fabrizio. Hi.
Thank you very much for listening to us.
No, it was great. Thank you so much.
Excuse me for being too long.
No, it was...
And I don't know. I hope that it was at least as instructive for you as it was for me.
Yes, it was. It was really, really great. Well, I'm always looking for this kind of experiments in a different kind of books and of course with different actors, but it was great to make the comparison with the ones that you are talking about. Of course, they are much more in the academy, and the ones that I deal with are in kitchen gardens or vegetable gardens or orchards, but it's very, very interesting how they deal with the same kind of topics, but of course with a different philosophical framework or theoretical framework. Thank you so much. Okay, thank you so much. Bye-bye. Thank you all. Bye. Thank you, Oana.